Hello everyone, and welcome to today's presentation. We'll be exploring the topic of what is an ITP, which stands for Inspection Test Plan. In this session, I'll walk you through what an ITP is, why it's important, and how it helps ensure our projects meet the required standards. We'll look at how it defines the inspection scope and sequence, what gets tested, the methods used, and at which stages of the project these inspections happen. We'll also see how it helps us comply with key standards like ASHRAE, NFPA 13 and 20, and SBC 601. To make this clearer, I'll give you an example related to duct fabrication, showing how an ITP guides inspection of materials and assembly before approval. Throughout the presentation, you'll notice icons representing inspection, checklists, verification, standards, and approval, which will help us understand each step. So let's get started and see how an ITP keeps our projects on track and compliant. Let's talk about why ITP is so important in our projects. First, it guarantees accountability, traceability, and documented approvals, which are all essential for maintaining high standards and clear communication throughout the process. By having these records, we can easily track what was done, when, and by whom, making sure everything is transparent. Next, ITP helps prevent repeated site errors and ensures that re-inspections happen promptly. This not only keeps the project moving smoothly, but also minimizes delays caused by mistakes. It's a proactive way to catch issues early and address them before they escalate. Another key benefit is that it provides confidence to our clients and consultants. When everyone can see that quality checks are in place and properly documented, it reassures them that the work is being delivered to the highest standards. For example, think about chilled water pressure tests. With an effective ITP, witnessing these tests ensures they are done correctly the first time, which prevents future leaks. This not only saves us from costly rework, but also keeps the project on schedule and within budget. And if you look at the icons here, quality goals, process control, cost savings, time efficiency, and performance, they all tie back to how ITP helps us achieve these vital project objectives. Now, let's take a closer look at the components of an inspection and test plan, or ITP. Typically, an ITP includes several key sections that help ensure quality and compliance throughout the project. First, we have the activity description, which clearly outlines what specific task or inspection is being performed. This sets the scope for each activity. Next is the inspection and testing methods. This part details how the activity will be carried out, whether it's a hydro-test, a visual inspection, or some other method. It's crucial because it defines the approach to verifying quality. Then, we come to the acceptance criteria or standards. This specifies the parameters that must be met for the activity to be considered successful. For example, in a hydro-test, this might mean no pressure drop greater than 1%. The responsible party section assigns accountability. Who is responsible for conducting the inspection or test, such as a QC engineer or a specific team? Witness or hold points are also vital. They indicate stages where an independent party must witness the activity or where the work must be held until approval is received. To make this clearer, let's look at an example. Imagine we're testing firefighting pipes with a hydro-test. The method would be a hydrostatic test at 10 bar for 2 hours. The acceptance criteria could be no pressure drop exceeding 1%. Responsibility might be shared between the QC engineer and a consultant who witnesses the test. Finally, you'll notice icons on the slide. These are visual cues. Page facing up for forms, wrench for methods, straight ruler for criteria, construction worker for responsibility, and receipt for records. They help quickly identify each component's purpose within the ITP. Understanding these components helps us keep our inspections organized, transparent, and aligned with project standards, key to ensuring everything functions safely and efficiently. Now, let's take a closer look at the approval flow for each inspection. To ensure full transparency and quality control, every inspection goes through multiple levels of approval. This structured process helps us catch any issues early and keeps everyone on the same page. The typical sequence starts with preparation, where we get everything ready for inspection. Next is the internal check, where our team reviews the work to ensure it meets our standards. After that, the consultant reviews the work, providing an expert opinion. Finally, the client gives their approval before we proceed to the next step. Let me illustrate this with an example, specifically for an FCU installation. First, our quality control team checks the mounting and drain slope to make sure everything is properly aligned and functioning. Then, the consultant witnesses this check to verify compliance with design specifications. Once they approve, the client must also give their approval before we connect the ductwork and move forward. Throughout this process, we use specific icons to symbolize each step: a brain for preparation, an eye for review, a pen for approval, a folder for recording, and a satellite for monitoring. This systematic approach helps us maintain high standards and ensures everyone involved is aligned from start to finish. Let's take a closer look at this sample ITP table, which illustrates an MEP example. Here, we see different activities listed, such as HVAC duct leak testing, fire pump testing, and plumbing pressure testing. For each activity, there are specific inspection types, standards or codes that apply, and acceptance criteria we need to meet. Notice that for the HVAC duct leak test, the pressure test must adhere to SMACNA and ASHRAE 90.1 standards, with a leakage limit of 10 cubic feet per minute per 100 square feet of duct. This is a critical quality measure to ensure system efficiency. Moving on to the fire pump test, it involves flow and pressure testing based on NFPA 20 and 25 codes. The acceptance criteria here are quite specific. The pump must deliver at least 150% of its rated flow at 65% of its pressure. This ensures the pump performs reliably under operational conditions. Finally, the plumbing pressure test uses hydrostatic testing standards from SBC 701 and ASME B 313. The key point here is that there should be no visible leakage after 30 minutes, confirming system integrity. You'll also notice the witness or hold points designated for each activity. These are the critical moments when inspections are performed, either as witness points or hold points, to ensure everything is checked thoroughly. Lastly, responsibility falls on the QC engineer, consultant, or QC inspector, depending on the activity. This emphasizes the importance of accountability and clear roles in the quality assurance process. By understanding these key details, we ensure our testing procedures are aligned with standards, meet acceptance criteria, and ultimately deliver a safe, reliable building system.